Go. Boom, we got it. All right. All right, so here we go. Networking. It's the basis of all how devices interconnect with one another. You know, I want to add to that is a process of sharing data across devices and applications. All right, I say that again. It's a process of sharing data across devices and applications. Y'all wonder how multiple cell phones can access YouTube at the same time? Networking. Ooh, look at you. Networking.
Fiber.
Networking, huh?
Networking. Okay.
Yeah.
I'm glad I got this recorded because I didn't write down what you said. I just want to be paying attention, and then I can come back and like.
Oh yeah, we're gonna take our time with this. I don't want you to worry about that. So basically, this networking thing is pretty cool. We're gonna go to our next slide here. All right. See right there? You putting all the pieces together in your network. And within networking, have you ever wondered how text messages and group chats work? You ever wonder that?
No, but I mean, it's good to know.
Well, you know what? Like I said, start with the application layer. The application layer, guess what? You got to learn what we call the OSI model. OSI stands for, you know what? You might want to write this down too. OSI stands for Open Systems Interconnection Model. Okay. You have 7 layers, and all the way at the top, that's a 7 layer, right? That's what we call the application layer. So this we use this every day too. Like I said, if you use your, like I said, iMessage, YouTube, GroupMe, I said any of your favorite apps, right? They all reside at the application layer. And through networking, that allows us to access these apps on all our devices simultaneously. I mean, I get on YouTube on my phone, you know, YouTube on your phone, and all your friends can too.
Open system what? OSI.
So that's the OSI model. That's the Open Systems Interconnection model. So, like I said, as we define networking, it involves the process of how devices share and receive data, information on the network. Okay, that's networking technology. The process of how devices share and receive data and information on the network. Okay, so just as 2 friends are communicating, you know, or writing letters to one another. I don't know if many people still do that here in 2022, but the same with that. You know that a mail service, you know, the postal mail works. What you have 2 things when you do that, right? You got a sender and you got a receiver. Guess what? Networking work the same way, because you're gonna have the sender device, which is gonna be the source device. That's where you get to the thing about source IP address, source MAC address. That's the sender, you know, sending that. And your destination is where it's going to, okay? So that's where you get the destination IP, destination MAC address. So the sender has a source IP and source MAC address. Your receiver has a destination IP address and destination MAC address. See how that works there? A little bit?
I guess somewhat.
Just a little bit. Ain't no way. If you ever get confused, just let me know now.
I'm just gonna listen and maybe something picks up, but I'm gonna ask questions for sure.
All right, okay. All right. So you got to send and receiver there. All right. So pretty much you got every device. We have a physical address and a network address. I bet you know what the physical address is, right? That's called what? What's that called? That's your physical address. That's your
which one?
I say so.
Yeah. My issue. Okay, go ahead. I'm listening.
No, you go first. I want to hear it. You go first.
I might be using the wrong terminology.
No, go ahead. Say it.
Not the IP, I don't think. I forgot what I was getting confused with. My octets. What is it?
Okay, so your IP address is actually gonna be your network address. All right. Your IP address is gonna be your address on the internet. All right. Your MAC address, that's your physical address. Mm-hmm. And see, MAC addresses, this is your physical address that allows devices to communicate on the same network, while IP addresses, however, allow you to communicate on separate networks. So that's how, so, you know, let's think about this. That's how computer one communicates with computer two on a separate network. Has to have an IP address, okay, to read to go out to separate networks. Now the MAC address, your physical address, that allows you to communicate on the same network. Mm-hmm. And see the way that they read here. See, for example, okay, the MAC address has what we call hexadecimal. That's a combination of letters and numbers. All right, you see, you got 00, and they use dashes between it. And IP address, however, they use periods, better known as octets. Okay, you don't have a series of periods in between. You got IP address be 10.0.2.122, for example. That would it look like. All right, so the OSI model. So you have 7 layers in the OSI model. Let's give you a foundation of all your devices and applications communicate within the network. So like I said, you know, we use it every day from Office 365. That's another application we use a lot. Your Cisco wireless controllers, all your Apple Store apps, your Google Play Store apps. So remember this acronym right here I'm about to give you right here. All people seem to need data processing. Say it with me. All people seem to need data processing. All right. And see, I want you to remember that. Guess what? The first letter in each word is going to represent a layer of the OSI model. You see right here, we say, oh, it's the letter A, right? That started layer 7. That's the application layer. Then you get down to people. Start with a P. Guess what layer that's going to be? Presentation. And then you get down to scene. S stands for session. I2, the T stands for transport. Need, N stands for networking. The data, D stands for data link. And processing, P stands for physical. Now that physical is down to layer 1. At the physical layer, we start talking about our cables, RJ45 connectors, our phones, our battery backups, all that resides at layer 1. See, what we have to understand, again, as we move forward, you gotta know what happens at each layer, right? Because see, at layer 1, physical layer, that's all the groundwork. That's on all the bits and bytes. When they go to layer 2, that's where the switches are handled. You know, at the data link, switch process frames. See that? And when you go get to layer 3, that's where we'll start working with routers, and our routers process packets. And see, that's the, and see, and the data just kind of keep, you know, kind of keep working their way on through. See, this right here will give you the foundation with what happened to all the information as it travels all around the network. See, like every time you will set up a server, time you set up a configure a router or a switch, you understand what happens when that data leaves that device and goes to the next. Now, see, one thing about the data, data being processed all day in the network, right? All day. But as it leaves each layer from layer 1 to layer 2, it's gonna take on a different form, okay? So that's when you're gonna probably hear a term called a PDU. That's a protocol data unit. That's when we start talking about, okay, that's where a bit turns into a frame turns to a packet when it goes from one layer to the next. You see what I mean? Mm-hmm. Just a little bit.
The acronyms again for.
All right, so you got, okay, I'm gonna start with that again. So you got all people seem to need data processing. So layer 7, you got application. The A stands for application. And when you say people, the P stands for presentation. And for scene, the S stands for session. 2, the T stands for transport. And need, the N stands for networking. Data, D stands for data link.
Data link.
Oh, yeah, data link. Link. Mm-hmm. And processing, P stands for physical. Mm-hmm.
Okay.
You got it? All right. Now this cool video here, this why I showed you the world skills when they were getting ready for the world games.
Yeah.
Mhm.
I was they look stressed.
He said, so they look straight. Now I had to do this right here. I did this
They look
when I was traveling. Huh?
stressed out. So they look stressed out.
You know, one thing about it, it could be a heavy job now, depending on like how many devices you have, like how many rooms you have to set up. I mean, but it's actually fun. That's when you can get your hand on all the technology. But see what you're gonna learn here is where, how long the job it
California.
actually took. Hmm?
Somebody was based in California or wherever they was at. It was
Yeah, nah, they was in that was in Calgary, in Canada for the World
Canada.
Game.
Yeah, yeah.
Mm-hmm.
They look stressed out.
Like this.
We have to build it from the ground up, and we have 2 weeks.
They're building a backbone
It don't
for a
take long.
world-class event, World Skills 2009 in Calgary, Canada, where nearly 1,000 young people from around the globe come together to test themselves against their peers in 45 different skilled trades and technologies.
It is the Olympics for the youth today taking skilled trades.
Connecting an event of this size is a huge undertaking. More than 900,000 square feet of Stampede Park need to be wired, so the on-site team has their work cut out for them. The build out of the infrastructure has to be fast, and it has to be right.
We have to run 96 additional fiber locations across Stampede Park.
And see what one thing you get to do, you get a chance to run like those fiber optics you see behind them. You get to run over between different racks and everything. They'll show you how to prove what we call cable management. That's probably trying to make all your wires look neat. That they run from one port to the next and everything. And I was gonna tell you about the diagrams, your network diagrams. So what we had to do, we had to create those using Microsoft Visio. So that way those diagrams show you the whole layout of the network, like what's happening all throughout the building, from one room to the next. All right, how one room connects to the other. Mm-hmm. So what you'll get familiar with that now. That'll be down the line. I don't expect that to happen right now at all. Just showing you, like you'll learn how to read that. Mm-hmm. You're gonna see about okay, how many access points in the building, connected to this access point might connect this side of the hallway. This access point right here might connect the other side of the hallway here.
Don't you think I need to be in some type of I know we're doing this online, but don't you think I need to try to get some type of role in it?
What you mean? We're talking about what now?
Like get a role in networking.
Yeah, of course. But you know what? Before you do that, we got some stuff. So a lot of base we
No,
got.
I know that.
Yeah.
No, I know that. I'm saying like you can't show me nothing. Like, don't you work from home?
Yeah. I do. I am. I got you. Don't worry. I got some more stuff I'm gonna show you.
Oh, okay.
Hold on one second.
To network all of the tents and buildings. And then we have 860 desktops, 120 laptops, 200 plus personal printers, 12 plotters, 450 cell phones have to be integrated into the data center, be able to send mass messages. And we also are going to be running 150 Cisco cell phones across the network.
In order to make it all work, there are more than 140 people on the job, including 10 students from the Cisco Networking Academy.
I couldn't sleep last night. I'm so excited.
These students are some of roughly 750,000 worldwide who enroll annually in Cisco Networking Academy to prepare themselves for careers in IT and networking. With more than 9,000 academies across the globe, students are learning hands-on skills through a curriculum that prepares them for valuable industry certifications.
They'll experience things that they'll never see that can't be taught. Because things change.
So it's not like you're just learning it.
What was that now?
So you put on pause real fast. Now, question. Is there any way that I could come down there and do anything hands-on? Like, how would I mean, would I be able to go into an office with you or something like that?
Man, all right, so well, you know what?
Access to a, huh?
You know what? I can set that up, but I'm about to kind of get back with you on that. But in the meantime, what we can do, I can set up a packet tracer for you on here. I can do that. You know, that way, how we can collab on here and do it.
Okay.
Because I know you're trying to get your computer straight right now.
Well, I got to get a new one. Like this, the whole right side of my computer doesn't work.
Really? Yeah.
Seriously, I can't even close it.
Yeah.
So-
We had to go and do something with that. But yeah, that's cool. That's cool. Hold on right quick. Let me try to go to the next slide here. All right. So right here, the layers of the OSI model. So you know what? Now this right here, what I really want to show you tonight. So we gotta get familiar with that OSI model. We're gonna know what happened at each layer. So at the application layer, you can see right here, it's for this called a network processed application, right? And you got different protocols operate at each layer too. So I'm just gonna start by giving you 3 of each layer tonight. Okay. So you got domain name service, DNS. Now, can you tell me what happens with DNS and why do we need it? You remember?
No.
You don't remember? All right. So
I
DNS.
remember seeing it in Active Directory. We didn't do so much.
Now you're gonna see this about all throughout IT work with
I
servers,
know.
everything. Oh, especially with servers, man, because DNS is huge with servers. Use it all the
So
time.
wait, you said right now you're about to give me 3 layers, right?
Now I'm about to give you 3 protocols that each
3
layer.
protocols. Okay, so we
Mhm.
doing DNS, DHCP,
Yeah.
and FTP.
Yep. So that's be at the application layer. We're gonna start with DNS though. This is called domain name system, right? All right. DNS, domain name system. And why that's important, guess what? It maps IP addresses to host names.
Okay.
So guess what? That's how you access Google.com. Google.com has an IP address. All websites do actually. Google.com has an IP address. That's how you know that you can reach it on the internet. And DNS is responsible for that.
Right.
All right. Yep. So you about to say, you ready for the next?
Yeah, I'm just right.
You ready? Yep, DHCP. Oh, now you know what? Now this right here, I'm telling you now, these 3, you really have to know these. So
I know.
DHCP. Now, can you tell me what DSP does?
No.
You can't. You got to really be able to tell me this one. Because you know why? That's the process of automatically assigning IP addresses to all devices on the network. And guess what? Servers are responsible for that too.
You said it assigns all IP, it assigns IP addresses to all the networks.
Yeah. The DSCP server is the automatic process of assigning IP addresses to all devices on the network. And servers do that. That's what we call a DSCP server.
Yeah.
Uh-huh. Yeah. Server admin. But and oh yeah, you gotta tell me this too. What does DSCP stand for?
Something about a host. I don't know.
What does it stand for?
Dynamic host.
Yeah, okay. Dynamic host. What else?
I don't know. Something.
All right. So dynamic is better known for automatic, right? That's the automatic method. Dynamic host configuration protocol. Yep, that's the automatic way. So now you know the automatic method for assigning IP addresses. What would be the manual method for assigning it? You remember that?
Wait a minute. Manual way for static.
Static. There you go, girl. It's static.
Yeah.
There you go. It's gonna be a static. So you got the manual method static IP addressing, and you got dynamic, which is automatic. There you go. And then the third protocol, this is gonna be a way that we transfer files from a computer. I'm sorry. We're gonna transfer computer files from a server to a client on a network. That's file transfer protocol.
Is this FTPs was set up? You could do that with mailboxes, right?
Mm-hmm. You sure can. FTP. FTP eases 1, 2, 3.
Yeah, I had it. Good though. I was doing research. I'm telling you, I was doing stuff I don't think I was getting paid for. For sure.
Really?
Yeah, not being no service desk. Service desk.
See, you know what? Before we get to the fun stuff, we gotta cover all the basics first. Cause see, like these basically they like they right here gotta be kind of just in the back of your mind. Like, okay, yeah, I know exactly what's gonna happen now. All right. So when you get down to the presentation layer, guess what? That's when you get down to the file formatting. You get out to the file formatting and encryption of all data packets. Okay. And presentation is just how the data is viewed to you anytime you access a web page, right? So you got different file formats like JPEG images, right? You got your MIDI audio files. You got MPEG picture files too. And I said these are all file formats here, as you can see, right? And at the session layer, that's a layer 5. That's where it controls all your traffic flow information. So you have protocols like SCP, secure copy protocol, your zip files, NetBIOS. So we need to know about that. Hold on a second. So with NetBIOS is important because you're gonna see that a lot working with servers too. It's basically where you know what it stands for.
Write this down.
Oh yeah, right. Yeah, you want to write them down. So NetBIOS, guess what? It's gonna be so simple when I tell you this. You're gonna be like, man, why ain't think of that? Network basic input and output system. And you want to know why that's important?
Yeah.
Because it allows applications on separate computers to communicate over a local area network.
It allows applications on separate computers. It allows. Trying to get it right. Did I say it right? I know.
No. Tell me again.
It allows separate computers to communicate on a local area network.
Yeah, but you know what you need to add? It allows applications on separate computers to communicate over a local area network.
Computer to communicate. Okay.
All right, SCP. You got a secure copy protocol.
Wait, I thought you said we were only doing 3 right now.
Yeah. I was just gonna give you another one.
You just going through time?
Huh?
So you was just going through this?
Yeah, because I want you to know that. I want you to know it.
I want to get it out of it. So type SCP.
SCP. See right here, at layer 5, SCP. You got secure copy protocol, and that's And that's a secure method of transferring file between a local host and a remote host computer.
Okay. Secure method of transferring. Am I saying it right?
It's a secure method of transferring files between a local host and a remote host computer.
Do I need to be okay? I study each one, like go online and study each protocol.
Yeah.
Okay.
I'm about to tell you what, like I said, right now, you know what? I want you to refer to that chart right here. So you know you can actually see each layer, right? You see what happened at each layer.
Yeah.
And then so you take the 3 protocol that I said that that we're talking about tonight,
Yeah.
and you kind of get a better understanding of why it's important, also how it works. That's what I want you to know so far. I don't want you to get into troubleshooting just yet. No, not yet. Not yet. We want to.
Troubleshooting what?
That's no. About to know. We not troubleshooting yet. That's all I was saying.
Oh yeah, no, I was just trying to see like get off fear and just like for home, just to go over the protocol that you gave me tonight.
Yep.
Try to learn more about them.
Yep. Yeah,
Okay,
right.
so I need to go back to this. You said secure method of transferring. I forgot.
So you got a secure method of transferring file between a local host and a remote host.
Okay. Mm-hmm. How long did it take you to explain this? How long did it take for you to retain this?
Whew, when I first started networking, man, probably about a good, honestly, no. I'm gonna say probably about almost 6 months. Mm-hmm. But like when I fully got comfortable, though, it was probably about a year. Mm-hmm. You know that came from doing it on the job, studying for my CCNA too.
And I just wanted to know, like, not even time frame, because I know everybody's different, and like to get like an understanding of what to look forward to, and maybe I should, try to go directly into the field. Probably even I really don't want to go to getting lower pay because they're not paying nobody up here. They're paying people like starting them off at like $20. It's this company that starts people off at 30. But the thing is, I don't really, like I told you, I don't really know SCCM like that. So that was my only kind of holdback. And the guy told me over the phone, he was like, you have SCCM experience. I mean, I've worked on it very briefly, but I'm not fluent in it. So that's the only thing. And that was for service desk.
Huh?
That was for service desk.
Yeah. So we take a thing way higher than this whole service desk thing.
I know. I'm just saying because I want to get my hands. I want to get my foot in the door. I'm not in the door at all. You know what I'm saying? I ain't even knocking on the door. I don't think.
Yes, you are.
Oh, well,
Yes,
I'm knocking on the door.
Yeah, I mean, it's a start though, So we gonna keep this thing going. But pretty much what I'm gonna say about the transport level. Now, this is gonna be very important. From layer 4 on down, all of them important, but the transport layer, you're gonna get asked about this a lot. Okay. This is where you have a end-to-end connectivity. This is how you can send an email from, let's say, from me to you or you to somebody else. All right. And at this layer, you have what we call flow control and error checking. All right. You got 2 protocols that also responsible for that. Now you definitely got to write this down. TCP is called Transport Control Protocol. All right. That's what we call a connection-oriented protocol. Why? Because this protocol ensures that all of your messages arrive in order, on time, and they're gonna.
Hey, give me some grapes right here. I need to write this down. The next
What
one,
happened?
protocol.
Oh,
Right.
what happened? I'm sorry.
You said connection oriented protocol.
Mm-hmm.
You said this right here. Okay. You start over from when you said why it's so important. I'm
Yeah.
listening.
So basically, it's a connection-oriented protocol because it ensures that all of your messages arrive on time, in order, and free of errors.
Okay. Make sure. So this is only for emails.
Huh?
This is only for emails.
Well, we know what, I said emails because I was using it for an example, but it makes sure that data,
Okay.
you can put messages in parentheses.
Okay.
You can put in parentheses because like that's what referred to like your end-to-end communication.
Mm-hmm.
Mm-hmm.
Okay. Let's say and make sure all your data arrives on time. Arrives on time. In order. And what was the last one?
Okay, so it ensures that your data arrives in order, on time, and free of errors.
Mm. Damn. You important as hell, ain't you?
Hmm?
I said you important as hell, ain't you?
Nobody for real. Well, yeah, I am, but yeah.
Okay, 'cause I'm gonna be like, stop.
But
Stop.
now, you know what I was doing? I got a little file I created for you.
For me?
Yeah, for you. For
Yeah.
you. Right
I
there.
can't. I can see something, but I can't see nothing. Like I'm trying.
You know, I put in my notes, man. I created that for you. So we gonna work with.
Okay.
Yeah,
You send it to me?
I will. I sure will.
You send it through email or you send it
But
through text?
I'm about to go in and text it to you. How about that?
Okay.
You gonna laugh at that though. At the end.
Hold on.
I,
Give me 1 second. I'm sorry. Can I please call these people because they tripping?
oh, go ahead. Go ahead. Go ahead.
1 second. I'm really getting pissed off at these people.
What's wrong?
They saying that my payment is past due when it's not. I paid it yesterday and I paid it in full for my fuel card.